Hello, Mark Wells from EFD Induction here. It's just a couple of slides and videos to demonstrate a test we did recently where we mounted an HHT with a fairly simple concentrated coil onto a Gullco KAT to demonstrate or trial actually how we could scan around a tube or a pipe and without having some complicated spring-loaded mechanism to maintain coil gap, we could use the Gullco automatic height adjustment system. Here's our setup. We had a 20-inch diameter, 20mm wall thickness pipe, 160mm wide coil, concentrated. Actually, these ceramic pieces are there just as guides if we use it in a handheld way, but in this case there's no contact either by the guides or by the coil face. HHT and HHT leads. Here's the Minac, only an 18 kilowatt unit. That's all we had available actually on this day. This is the KAT unit, Gullco KAT. Google it, you'll find plenty of information on this proven equipment. Ultrasonic distance measuring device and height adjustment device, which meant that we could keep the coil away from the pipe at the right gap, plus or minus 1mm all the way around, which is good enough for what we wanted to do. And we're running 18 kilowatts, as I said, and we're running at 2 meters a minute in both directions around the pipe. We can heat in both directions. This video is showing you the Gullco height adjustment unit, and here is where the ultrasonic device is attached, quite well protected in this welding nozzle. And you can see that just by placing an object, or as the nozzle would go over something of a different height, it would raise or lower to compensate for that. And so far, the tests we've done, we can't see any effect on running that next to the induction coil. Just to demonstrate that we can, if we want to, go all the way around. When we did the heating test, we only heated 180 degrees around, but yeah, we're heating here. It's running fully all the way around, and we're probably peaking at 180 degrees just after the coil. And the limitation is obviously the cables and the pipes to come around. We speeded up the last bit of the video just because it would be rather boring otherwise. So this video will show you actually a recording of the computer screen that we're running the thermal imaging software on. On this side, in this window, you can see the real video image or normal video image showing the pipe and the ring. In this main area is a thermal image. This one is showing the temperature in this window here, and on the right side we can see the temperature displayed in area 2, 3, 4, 5, 6. So we've gone by one time with the coil, and we can see that if I was fast enough, you can see we exceeded 180 degrees directly behind the coil. And now with time to soak in a little bit of conduction, then we're left with a residual heat around 80 degrees. And now we come back. Remember, we're only doing 180 degrees rotation here. So we're going down to the bottom, stopping and then returning. And now our peak went over 200 and the residual heat around 120. Now I've speeded the video up because, well, I don't want to bore you. This is the third, fourth passes. And residual heat again is risen, and now 170 plus on pass 5. We're around the 200 degrees, and on the last pass, pass 6, we're up to 220 degrees plus. Now we could scan again. We could also make a coil wider or narrower, and we can also use different speeds, slower or faster, and we can use more or less power. But hopefully this demonstrates just how simple and easy it would be to have a non-contact induction coil running reliably around a pipe or tube, and if we balance speed, power and distance, we know we get the same repeated result every time. So thanks for taking a look. I'd like to say thanks to Brendan Gallagher from Gullco UK for assisting us and loaning us their KAT system for these tests. Thanks. Bye.